Hello students. Hello students. Hi to everyone. My name is Dr. Venkatesh Reddy, working as Associate Professor in the Department of Electronics and Communication Engineering, KITS Warangal. I'm the academic coordinator of the department. So in this semester, I'm going to teach you the subject called antennas and wave propagation. This is for 5th semester ECE students. The course name is Antennas and Wave Propagation, and the course code is U18EC 504. These are the course details. Course name, as I mentioned, Antennas and Wave Propagation. Course code also I have mentioned, U18EC 504. This is for BTech 5th Sem, and teaching scheme is every week 3 lectures and 2 tutorials, and this is a 3 credit course. And examination scheme is for 100 marks. Out of 100, continuous internal evaluation for 40 marks, and external evaluation, and that means end examination, is for 60 marks. In the internal evaluation, out of 40 marks, 30 marks for mid-semester examinations, and remaining 10 marks for the remaining 10 marks is the average of 6 components. As you all know, the 6 components are assignments 1, assignment 2, minor 1 and minor 2, special assignments on course patent 1 and course research paper 1. We will upload course patent and course research paper in the course web. You have to submit the 2-page summary report on this course patent and as well as course research paper. The 6 components, average of the 6 components, we will consider it for 10 marks, and remaining 30 marks for mid-semester examination, total 40 marks for internal evaluation. End examination for 60 marks. As part of the teaching learning practices, in our college we are having course web, which is the interface between the faculty and student. It is the interface between the teacher and the student. Teacher will upload everything in the course web, starting from syllabus of the course, outcome-based lecture schedule, and course videos, and self-learning topics, and tutorials, assignments, and special assignments on course patent and course research paper, and minor examination patterns, mid examination pattern, end examination question paper pattern. Everything is uploaded in the course web. You have to regularly visit the course web, and you have to submit all the assignments. And course videos also we are going to upload. That means tomorrow's lecture that is going to be discussed in the classroom, based on the same topic, a video will be posted ahead, and that video you have to listen, and then you have to attend the tomorrow class, and you have to get clarified all your doubts. As we are in the industry 4.0, active learning is important. Student has to actively involve in the teaching learning process. Student is the active learner. It should be student centric teaching learning process. So accordingly, you regularly visit the course web and submit all the assignments, and listen to the videos, and watch and download the course discussion topics, summaries on the course various topics, and read those. Those are definitely very much useful. This course is basically a higher end course, which is until now we have seen electronic circuits and electronic related subjects. And from fifth sem onwards, you will see the communication related subjects, digital communication, analog communication systems, and antennas and wave propagation. And these are all higher end subjects. You have to put a lot of concentration on these subjects to understand. The course learning objectives are: this course will develop students' knowledge on radiation mechanism and antenna properties. What do you mean by antenna? How is the definition of the antenna? Where it is used? Why it is used? How it radiates the electromagnetic energy? You might have seen antennas on rooftops as well as in your real on day-to-day basis. You might have seen several antennas which are tower antennas and all these things. How they radiate? What is the radiation mechanism behind that? What are the properties of these antennas? Like all other electronic devices, antenna also will have certain properties like gain of the antenna, directivity of the antenna, beamwidth of the antenna, radiation pattern. All these things we are going to understand from the learning objective 1, radiation mechanism and antenna properties. Learning objective 2 is linear antenna arrays and its radiation patterns. As a single element is not sufficient for more number of applications, so we have to go with antenna arrays, where group of elements are arranged in particular fashion. Group of elements are arranged in side by side or in different configurations, so that we can enhance the antenna properties. You can get the required antenna properties by going with antenna arrays. And learning objective 3 is types of antennas used at microwave frequencies, ultra high frequencies, very high frequencies. What is a band, very high frequency band? 30 megahertz to 300 megahertz. What is ultra high frequency band? 300 megahertz to 3 gigahertz. What is the microwave frequencies? 1 gigahertz to 100 gigahertz frequency band is called as microwave frequency band. What are the antennas that are used at these frequencies? That also we are going to see in this course. And lecture objective 4 is wave propagation. Once the antenna radiates the electromagnetic wave, how it is propagating in the free space, in what direction, that means what type of propagation it is taking place, whether it is by surface wave propagation or space wave propagation or sky wave propagation. Okay, these are the 4 learning objectives. The syllabus, when it comes to the syllabus, unit 1 is consisting of linear wire arrays, introduction to antennas, radiation mechanism, retarded potentials, radiation from small dipole, half wave dipole and quarter wave monopole, current distribution, electric and magnetic field components from these small dipole, half wave dipole, quarter wave monopole, and radiated power. What is the radiation resistance of these elements? This comes under part 1 of unit 1. And second part is the antenna properties. As I told, like all other electronic devices, antenna also will have certain properties: radiation pattern of the antenna, beam width, radiation intensity, gain, directivity, bandwidth, polarization, antenna impedance, effective length, aperture concepts, and reciprocity theorem applied to antennas, and phase transmission equation. All these things we are going to learn from unit 1. Antenna properties, like when you go to the market, how do you ask that? How do you give the specifications of antenna? Based on these properties only. You'll ask the vendor that I want a 5 dB omnidirectional antenna. I want the antenna for microwave frequencies. I want the antenna for UHF frequencies, VHF frequencies. These are the antenna properties: gain, radiation pattern. I want a very pencil beam antenna. I want a narrow beam antenna. I want a narrow bandwidth antenna, broadband antenna. These are the properties are very important. Unit 1. Unit 2 is about linear antenna arrays. As I told, single element is not sufficient for many applications. You have to group the elements in certain fashion. You have to arrange them in different configurations, geometrical configuration, so that we can enhance the antenna properties. Okay, binomial arrays and the concept of phase there also we will discuss in unit 2. Non-resonant antennas like traveling radiator antennas, V antenna, inverted V antenna, rhombic antennas are also discussed in unit 2. Unit 3 is about a very high frequency, ultra high frequency and microwave antennas. Basically 6 antennas, real world antennas are discussed here. Azimuth antenna and folded dipole antenna and parabolic reflector antenna, horn antenna, helical antenna, and microstrip antennas are the one which are recently introduced in this URR 18 course. Rectangular microstrip antenna. This is the current research topic that is going on in microwave antennas. Unit 4 is about wave propagation. What are the factors involved in wave propagation? Ground wave propagation characteristics, wave tilt, flat earth considerations, ionosphere formation of layers and mechanism of propagation, reflection and refraction mechanisms, critical frequency, maximum usable frequency, optimum working frequency, skip distance, virtual height, space wave propagation, M curves, and duct propagation and tropospheric scattering. All these things will come under Unit 4. The textbooks that I suggest you, Jordan and Ballman, authors. The title is Electromagnetic Waves and Radiating Systems. And John D. Cross is another very prominent author, frequently used in when you're referring to antennas. Frequently we listen John D. Cross name. The Antennas and Wave Propagation by John D. Cross is another textbook I suggest you. And the reference book is Constantine A. Balanis, Antenna Theory, and GSN Raju, Antennas and Wave Propagation, KD Prasad, Antenna and Wave Propagation. These are the textbooks and reference books. What are the course learning outcomes? After completion of this course, students will be able to discuss the radiation mechanism and fundamental characteristics of antennas. This is the course outcome 1, and course outcome 2 is design 2-element and n-element arrays. We should be able to design an antenna array for a specific application. We should be able to design an antenna array for generating or obtaining a pencil beam. Course outcome 3 is build UHF, VHF, and microwave antennas. You should be able to design antenna for TV reception, TV signal reception, antennas for mobile phones. You should be able to build, should be able to design UHF, VHF, and microwave antennas for. This all comes under course outcome 3. Course outcome 4 is about distinguish the ground wave, space wave, and sky wave propagation. This is very, very important subjects, antennas and wave propagation. What is the definition of introduction to antennas? What do you mean by antenna? Antenna is basically a metallic device which is used for radiating and receiving electromagnetic signals. Once you want to transmit the electromagnetic signal, you take the help of antennas. Antennas are basically our links with the space. They are our links with the external world. Antennas are our electronic eyes and ears on the world. They are our links with the space. They are essential and integral part of our civilization. When it comes to Webster's dictionary, it is usually a metallic device for radiating or receiving electromagnetic waves. In IEEE standard, it is defined as a means for radiating and receiving radio waves. In other words, it is a transitional structure between free space and guiding device. Antenna basically converts electrical quantities like voltage and current into electromagnetic waves or electromagnetic fields, electric field and magnetic field, and vice versa. At the transmitting side, at the transmitter side, it converts electrical energy into electromagnetic energy. At the receiver end, it receives electromagnetic signals and converts them back into electrical signals. So it is a device for radiating and receiving electromagnetic waves. It is a transitional structure between guiding medium and free space. It is a transducer which converts electrical quantities into electromagnetic waves. Definition of antenna. Antenna may be a piece of conducting material in the form of wire or any other shape with excitation. An antenna is a source or radiator of electromagnetic waves. An antenna is a sensor of electromagnetic waves. An antenna is a transducer. An antenna is an impedance matching device. An antenna is a coupler between a generator and space, vice versa. The learning outcomes of the today's class are you should be able to define antenna. If somebody asks that, as an electronics engineer, somebody asks that what is an antenna? If you are able to define antenna, they definitely will have a bad impression. So define antenna in IEEE definition, in Webster dictionary definition, it is a metallic device for radiating or receiving electromagnetic waves. It is a transitional structure between free space and guiding medium. Okay, this is the learning outcome or the course outcome of the today's class. In the next class, I will introduce retarded vector potential, and we will develop the expression for power radiated from a small dipole, which is called as Hertzian dipole. Okay, with this, I'm closing the today's session. Thank you.